The process of finding the domain of the function is as follows. So we usually start with the domain being the set of all the real numbers, and then find if any of the x values have to be excluded. And then for the things that should be excluded, those are usually zeros of denominator, because those x values will cause division by 0. And another set of x values that usually needs to be excluded is the x values that make the content of an even index radical to be negative, because we cannot take square root of a negative number or fourth degree root of a negative number and get away with a real answer. So let's look on those 4 examples. So for the first example, we have the question of finding the domain of the function, which is x squared minus 1. So in this function, there is there is no denominator, so there is nothing to exclude based on the denominators. And on top of that, if you look on the formula x squared minus 1, there are no even index radicals. So there is no square root or anything like that. So there is nothing to exclude from the domain. So that means that the function f of x will be defined for absolutely all values of x. So the domain will be negative infinity, positive infinity. Now shifting to the second example, this function f of x being the fifth root of x squared minus 1. So again, quickly examine these functions. So there are clearly no denominators in it, so there is no fractions at all. There are no fractions at all. And then the only radical that we have is the fifth degree root. And the fifth degree is not an even degree. So there are no even roots, there are no even index radicals in this function. So again, the domain for that function will be all real numbers. So the domain will be interval from negative infinity to positive infinity. Moving on to the third function. This function is f of x being equal to x over x squared plus 1. So for the denominators of this function, there is x squared plus 1 in the denominator. So to find if we need to exclude any x values from the domain, we solve x squared plus 1 equals 0. It's exactly denominator being equal to 0. So if you subtract 1 from both sides, you have x squared equals negative 1. So that equation has no real solutions. So that means there is nothing to exclude from the domain, because this denominator, x squared plus 1, will never be equal to 0. And on top of that, there are no even index radicals in this function. So there is nothing to exclude from the domain. So domain again ends up being all real numbers from negative infinity to positive infinity. Now moving on to the last function, so it's f of x being 1 over x. So there is a denominator, x is in the denominator. So if we solve x equals 0, the solution will be x equals 0. So there is nothing really to solve in this equation. So what we're going to do, we're going to exclude x equals 0 from the domain. And there are no radicals in these functions, so there is no need to worry about those. So here's our real number line, so all the x values are here. And we're going to exclude x equals 0 from the domain, so we're going to put a punched point at x equals 0. So everything else will be in the domain, so I shaded it in green. So the domain will be the interval from negative infinity up to 0, with the parentheses, union with the interval from 0 up to positive infinity. Again, parentheses everywhere. So that's the union of those two intervals is the domain of the function 1 over x. So let's start with the first function, f of x being x plus 3 over x squared minus 16. So if we look on this function, then we notice that there is x squared minus 16 in denominator. So start by solving x squared minus 16 equals 0 to determine the x values that need to be excluded from the domain. So add 16 to both sides, we get x squared equals 16, so x is equal to positive or negative square root of 16, so x is equal to positive or negative 4. So that gives us the reason to exclude x equals 4 and x equals negative 4 from the domain of the function. And so we're done with denominators. That was the only denominator in this function. If you look for any even index roots in this function, you don't find any. So I'm going to make that statement that there are no even index radicals in this function. So putting all of those findings together, we have all the numbers, and we're going to exclude negative 4 and positive 4 from the domain. So what is left? We're left with 3 intervals of x values, and those 3 intervals will be the domain of the function. So the left interval is interval from negative infinity to negative 4, and we have parentheses everywhere since negative 4 is excluded. Then second interval is from negative 4 to positive 4, and the last interval is from positive 4 to positive infinity. So the union of these 3 intervals is the domain of the first function. Now moving to the second function, the function is square root of 7x plus 11. So we notice that there are no denominators in this function. But there is an even index radical, that's the square root of 7x plus 11. So to keep the square root out of trouble, we're going to keep the x values that make 7x plus 11 greater or equal to 0. So solving that inequality for x will give us 7x is greater or equal than negative 11. So divided by 7, we get that x is greater or equal than negative 11 over 7. So we better put that on the number line. So this is the number line of x values, and this is the negative 11 over 7, and everything greater than that value and including that value will be in the domain of the function. So for the domain, we get this closed interval from negative 11 over 7, including the endpoint, up to positive infinity. So the single interval will be the domain of the function 7x plus 11 inside of square root. And contrast it with this function, the last function f of x being cube root of 7x plus 11. So this function has no denominators, but then it has only third degree roots, so there are no even index radicals. So that gives you absolutely no restrictions on the x values that could be used in this function. So the domain will be all real numbers from negative infinity to positive infinity. And let's start with the first one. It's f of x being equal to square root of x plus 5 over x squared minus 16. And examining the formula for the function, we see that there is denominator x squared minus 16. So to determine the x values that need to be excluded from the domain, we're going to solve x squared minus 16 equals 0 equation. So going ahead with that, we move 16 over and look on x squared equals 16. So x is equal to plus or minus square root of positive 16. So x is equal to positive or negative 4. So we're going to have to exclude x equals 4 and x equals negative 4 from the domain of the function. But on top of that, there is an even index radical in the formula for the function. It's square root of x plus 5. So to keep that square root out of trouble, we're going to keep only x values that make x plus 5 greater or equal than 0. So solving that for x, we have x being greater or equal than negative 5. Now we're going to put all of those restrictions on the real line. So first of all, we said that we're going to exclude x equals negative 4 and x equals positive 4 from the domain of the function. So I'm gonna put punched points at -4 and +4. And then we said that to make the square root happy, we have to have x being greater or equal than -5. So we're going to shade everything that is to the right of -5, with the exception of -4 and +4. So these three intervals are shaded in green, and they will make up the domain of the function. So domain will be the interval from -5 to -4. -5 is included and -4 is excluded. Then the second interval is the interval from -4 to +4, that's this open interval. And the last interval is the interval from +4 to infinity. So all of that makes up the domain of this function. Now switching over to the second function, which is f of x equals 2 minus x to the 4th over square root of 3 minus 2x. We notice that there is a denominator that contains square root of 3 minus 2x. So for the purpose of avoiding division by 0, we solve square root of 3 minus 2x equals 0 equation. That gives us 3 minus 2x equals 0. So it's 3 equals 2x, so x is equal to 3 halves. So we're going to exclude x equals 3 halves from the domain to avoid the problem of division by 0. And now, since we have even index radical in the formula, to keep that out of trouble, we're going to keep x values that make 3 minus 2x greater or equal than 0. So solving that for x, we end up with x being less or equal than 3 halves. So to keep the square root of 3 minus 2x defined, we have to use values of x less or equal than 3 halves. Now putting all of that together on the real line, so first of all we're going to exclude x equals 3 halves because that value causes division by 0 problem. So put these 3 halves as a punched point. And then for the sake of the square root, we're gonna use only x values that are less or equal than 3 halves. So shading everything to the left of 3 halves, we have this single interval for the domain. And domain of this function will be interval from -infinity up to +3 halves. And this 3 halves value is excluded because there is punched point there.